Okay, good afternoon. Welcome in our presentation. Again, one about AI, but this time in another complete other aspect of the AI landscape. My name is Koen. I'm CTO of Listerius, and I'm one of the dinosaurs at Listerius, playing with FileMaker since 1998. And you could also know me as one of the MVPs in the Claris community.
Yeah, my name is Mireia. I'm the baby FileMaker chick here. I joined Listerius Spain a year and a half ago, and well, I'm a former basketball player and an industrial engineer.
And before we start, we want to thank an internship at us who started playing with these kind of models and guided us throughout the whole journey. She had that in her curriculum. They learn these days at school AI, and it was really a help for us to explore that technology and have a little bit a deep dive in there. Yeah. Before we start, has anyone played with regression models in FileMaker 2025? Yeah. Was anyone aware that there were regression models in 2025? Okay, it's good to see. Yeah. So first we're going to talk about what is regression and where does it play in the landscape of AI. Then we have a small walk through the random forest. This is one of the techniques to do regression models, and that's the one that Claris has chosen to do. We will explain how it works. We will show you how you use that model, and then more important, how you train one. And then the last one is how are you sure that your model is okay or not? Just a quick disclaimer. We are not data scientists, but we love and admire science. We are not mathematicians, but we like math. And sometimes we have to look to the legal side of AI as well. And no, we don't like legal things.
So good news are Koen is taking us to New York today. But before we get there, I would like to explain you what is regression. Anyone has done any type of regression ever? No? Okay. So regression is a process that allows us to estimate a value depending on some features that influence the value we want to estimate. So to make it simple, let's say we have just arrived to New York, fast trip, and we want to take a taxi. So we know that every kilometer we do with the taxi, it's going to take 4 minutes. And just by knowing the distance we need to travel, we can estimate more or less the arrival time, right? Simple. So if we have a trip of 2 kilometers, it's going to take 8 minutes. You have all done regression now. Perfect. There are 2 buts here. One, how do we guess that each kilometer is taking 4 minutes? We can guess it because we have some historical data with both information of the features and the output, the variable we are trying to calculate, that can allow us to find some patterns, right? What's the goal of using regression? So for using regression, we need, as I said, some historical data. And the other but is that usually it's not that easy to guess an estimation. In real life, we have much more variables that affect the result. So for example, for the taxi trip, it could be the weather. It could be if it's a weekday or the weekend. If that's the marathon day, it would probably take longer. So yeah, things are going to get a little bit more complicated. Good news are that we don't have to be mathematicians to get the results, but the regression model is going to help us. And of course, it will only make sense if we find a business case and we have a client who needs to estimate some results, right? I think that starting with us, it has happened many times that we say, yeah, this project is going to take just 3 weeks, and you find yourself working on it 6 months later, right? So guessing might not be the best method, and unfortunately, most of real use cases are not simple mathematician rules, so that's why are we presenting today this new tool that FileMaker is offering.
Okay, let's make it a little bit tangible. So we work with an example because one of the most difficult things in our preparation was, in fact, how we show it. We can not use just customer data. And so good websites to play around with is Kaggle. It is mentioned in some sessions today. They have a lot of test data available and exercises available to build your own models. Not only with the LLM models that you see in the other sessions, but also with other kind of models. And people share also their results. I've played with that data set, and this is my code, this is my results, this is how I did the exercise, and so on. So it's really a learning resource, so worthwhile to have a look on. So what did we download? Well, a data set with bicycle crossings for the bridges in New York. So we want to visit some places in New York and want to see if it's not too crowded on that bridge to pass over. Yeah? If we have a look in that data set, it contains some historical data we imported that is freely available. So what do we have? We have a bridge in New York. We have a date. We have the weather conditions on that day. And we have the number of bicycle crossings that they have counted that day. So, as Mireia explained, so we're going to estimate a number, the y. So what is the number here? That is the number of bicycle crossings. That is how we're going to train our model. And a regression model can only predict one figure. Yeah? So if we, for instance, would need a second model to predict the number of cars passing a bridge, we would have to make another model. Yeah? And then we have a couple of features, what is called. What are the variables that have influence on that model? So in our case, the bridge is important. We have chosen to take the month and the day of the week. We left out the year, for instance. We took the low temperature, the high temperature, the precipitation, and if that precipitation was snow or not, because if it's snowing, taking a bike is not that fun. And then we have to look for what kind of method will we use to build a regression. And there are a lot of regression methods. One well-known is linear regression. You have polynomial regression. Claris decided only to build in random forest. To explain a little bit linear regression, like Mireia already told, we have a lot of historical data points, and with some simple mathematicians, you can have a formula that predicts the number. That's the red line, the regression. For random forest, it's different. That's why it's so good with dirty data. You ask, in fact, experts to give an answer. So in this case, you ask an expert, based on the situation today, what do you think will be the number of crossings today? And you ask him a couple of questions. If you ask one taxi driver how long will take the trip, you will get a number, but that's maybe not correct. So what you do is you ask that to multiple taxi drivers, a lot of them. It's called a tree. And you don't ask every time the same question. You randomly ask some questions about your data to get a number, a guesstimation. And what is random forest doing? Random forest gives back an average of that estimation. Yeah? And the more random your forest is, the better the prediction you get.
Okay, so we are going to learn now how to use a model. We will start with a demo we prepared. It is about the same data set Koen was presenting, which is the bike crossing in New York. So let's say, we will learn later how to train a model and how to test a model, but let's say that we have our model already prepared and stored in a container. And we are just gonna go to try to predict how many bikes are gonna cross today, one bridge in New York City, right? So what we only have to do is we have to introduce the features of the conditions today. Let's say today we want to know how many bikes are going to cross Manhattan Bridge. I've checked the temperature before. The lowest, it's in Fahrenheit, so it's 32, 43, but I think it stands for kind of between 0 and 6, so the bikers are going to be quite brave. Let's say there's a bit of precipitation and that there's snow. So just by, and I forgot the most important part. We didn't choose any model. Let's choose one model, and let's ask FileMaker to predict how many bicycles are going to cross the bridge. We got the number here. 1,800 bikers are going to cross today. And now I'm going to show you how did we get this result. How do you go back here? Comment up. Okay. Thank you. So what did you use here? We used a regression model that was loaded in memory, a list of features in the form of a vector, and the new FileMaker function predict from model. Okay, let's go one by one. And of course, what did we not use? The Clarice AI service server, a commercial LLM provider, but we can use it for some cases we'll see later as well. So the regression model is a model which is stored in a container field, and we have to give him a name. So the first step to use this model is to use the script step, configure regression model, and load the model into memory. Then we can use it, and when it's not used, when we don't have to use it anymore, we can just unload the model so it deletes from the memory. The features we were using were exactly the same that Koen showed that they were on our database. And basically what we did was to put every feature in one position of the vector. So each bridge had its own ID, 1, 2, 3, 4 for the 4 bridges we had, the month, day of the week, lowest temperature, highest precipitation, and 1 and 0 Boolean if there was snow or not. How do we build this vector? It's quite easy. It's just function JSON set element, and in one step you get it done. And then we use the function predict from model using the model name that we set on the container before and the features we had just built. So all in all, very simple. We create the vector, we use the function predict from model, put the name of the model we had just created and the vector, and you get the number back. One important thing we have to take into account here, and we will see it later, is that the order of the features on this vector needs to be exactly the same one as the one that you use for training.
So now we have seen that, that model, and if you ask how big is that model, it's only a couple of kilobytes. So it can be a couple of megabytes, but then FileMaker has a little bit struggling with loading into memory. So what do we need to train this model, to make our own model? Well, we need data, qualitative data. And we need 2 kinds of data. One that we use for training, and one that we will use for testing. Then we have to do, like you have seen, a number of features. We have to select which features have an influence on the number we can provide. So that must be in that historical data and must be cleaned up. We need a script step from FileMaker. There is a new one in 2025 to train that model. The same one we use to load the model can also be used to train the model. And, well, you need some patience and time from time to time, because if it's building a model, it takes the computer quite a while. Again, what is not used to train our model, this has nothing to do with the LLM models we're using, so no commercial providers involved, no Clarice AI server involved. Yeah? I train my models on my local computer, not on the FileMaker server, just to avoid latency issues and so on. Yeah? So let's have a look in the application. As you might have seen, we have here some configurations, and we will explain all the figures you see here, what these configurations are. But in fact, we have training data. And the training data is done on 70% of our selected data. That's a good figure to play with. So we train with 70% of the data, qualitative data, and 30% will be used to test our model. Yeah. I come back on the numbers, what is enough data to train things, and what is too much in that case. And then you train your model. I will not press on the button now, because then we can wait sometimes until the session is done, depending on the parameters. So we skip that part. So first of all, and spend a lot of time on it, this is more complex than the technology behind it. You need relevant and real data, useful data. And you have to analyze it and also see if there are no outliers. If, for instance, the road was closed due to an accident, then, but that parameter is not in our data set, you want to leave that out of your prediction model. Also, data that is not complete, that does not contain any values, you should leave out. If you build that inside your own application or your own environment, knowledge of your data is in fact key. Understanding what the data is doing and doing analysis on this is key. So take a lot of time on this in your preparation. So must be a good sample size, and a good sample size in FileMaker is hundreds to thousands of records. If you start building models with 30,000 or 40,000 or 100,000 of data, it will take a long time, and probably your model will not load in FileMaker because it's too big for the technology. So it has to be representative, it has to be cleaned out and pre-processed so that it's optimal for your training, and it should be real data. Sometimes in science, they don't use real data. They want to prove a model. Then in science, it will work a little bit different. But it should be, you should have actual results to check if your model is working fine. And then we need a test data set, which has, in fact, needs the same kind of specifications. Future relevance, that's also a difficult one. How do you know that a certain feature is relevant for your model or not? That's trying out. That's building multiple models and seeing what influences what. The better you know your data yourself, the better you can determine what is and that is important or not. If we would have, for instance, a name of every biker that crosses the road, that's maybe not a good feature to have in our set. So the same thing, we need to prepare vector embeddings for our data, exactly the same one as Mireia showed. And then we have a big script step in FileMaker. But instead of loading the model, we're going to train the model. So the action is train a model. The algorithm is random forest, but that's the only one we can choose today, unfortunately. We need a field, and it has to be a field where the vector data is in there. And then we need the target value. In our case, the number of bicycle crossings that we will feed to the model to learn from it. Yeah? Well, if there are some bad records in there, you can have an option to skip it. I don't know why we wouldn't skip it, but it's an option. Then we have some parameters we have to add, the same parameters you have seen in my application, and we will explain them one by one hereafter, because it can be a little bit confusing on that side. And we need our container field where we're going to save the model. You see it has a .fmreg extension. If you open it for curiosity, it's a text file with a lot of numbers in there and some text.
So we are going to talk now about the parameters that Koen just said that we needed to configure a model. There were 5. The first one is the number of trees. So it would be like the number of taxi drivers you ask for the duration of the trip. Like how many trees are you gonna ask? The thing is that it comes to a point that even if you ask to more people, they are keep going to say more or less the same, so it doesn't give you added value to it, but it makes the model slower. So you have to try to find an accurate number. So where the curve flattens, it doesn't make sense to increase the number of trees anymore. Unfortunately, now getting to this number is a little bit a trial and error situation in FileMaker.
So in other environments and other tools, you sometimes have functions that predict what is the optimal tree for your data set. And unfortunately, that we don't have today. So it's indeed testing out a lot of models and see where you have the sweet spot.
Yeah. Okay. So the second feature that we have to configure is the maximum depth of the tree. It means like how many levels of questions are you going to make? So you can have like a bush or a huge tree. The problem with that as well is that if you make it too small, it can simplify your patterns and it won't rely to the problem you're looking for. But at the same time, if you make it too high, you have the risk to overfit. So again, you see if it's too small, you don't get a good accuracy. If it's too big, neither. So you have to find the optimal point there. That's an example of overfitting. This tree doesn't even fit to the screen, and it would take all the possible cases, so it's kind of memorizing and not finding any kind of pattern. So that's not what we are looking for, right?
So yeah, it's too precise, and then you get numbers that doesn't make any sense anymore. So better is not always better in random forest. Eh?
Then the third parameter is the minimum sample split, and it means how many samples do you need or how many cases do you need to decide, okay, that's going to be a new branch of my tree, to make it kind of easy. So again, if you make it with too few examples, it can lead to overfitting because it's going to take maybe one exception as a normal case. But if you ask for too many samples, it can also simplify the things too much or not take into account some important features. So again, we have the same kind of graph here. And then the two last ones are kind of related. There's the number of features and the maximum features, and I'm going to explain which is the difference between these two. The number of features, we usually set it to -1 because, as Koen said, it's really important to choose the features that are actually having an effect on the result and not taking features that they don't make any kind of sense, like the name of the bikers on our case. So it's more important to choose the features well rather than setting this number to an actual number, and we leave the configuration of this number to -1 to take them all. And the maximum features allows us to get some randomization. It means that not every tree is going to see the full picture. So some trees are going to be able only to see, let's say if we have 100 features, some trees are going to be able to see 10, some others another 10, and this gets us the possibility to randomize our trees and get a good result. But sometimes we don't have that many features. So if the features are really small, we could configure the maximum features to 0 so that the system takes them all. The problem is that if all the trees are seeing all the features, you lose this randomization and you can lead to overfitting again. The most used case is the square root, where you just literally make a square root of the number of features you have. Let's say if it's 100, each tree would look at 10 random features. And there would be another option, which is using the logarithm. But in this case, you get even less features. So you get higher randomness, but then to compensate, you will probably have to add more trees.
So if it feels overwhelming, it was for me as well in the beginning. So what does it exactly mean, and what does that really do? So one of the things we did is we were then on the testing. How do we test then if our model is okay? So Just if you start training a model, don't be afraid your computer is not phrasing. You see sometimes no feedback from Claris for a long time, and sometimes you get these dialogues, and the right one is can be stuck on that thing for a couple of hours, depending on the amount of data you have. And the other one is training the model, and it does that per tree. Yeah? The bad thing is, after a couple of hours in one of my models, I saw, oh, we are on 99, almost finished, but it's counting down, not up. Yeah? So it uses a lot of CPU, not GPU, strangely, but it uses a lot of CPU, so don't do a Teams meeting when you're trying to do a training, because you can see the effects happening. Also, I used the setAI call logging just to see what happens under there. It doesn't log anything, so it's only used for a LAM. Yeah? But have some patience. Maybe a good thing is if you have somewhere a Mac Studio or a Mac Mini somewhere, you could upload that task to them, or have a couple of computers that test out a couple of training. Don't think it's always hours. Some of our models were just trained in half a minute as well, so depending on the parameters. And even these models that were trained fast gave back good results. So it really depends on all the number of data, number of parameters, the amount of features, and so on. So evaluation, how does it happen? So don't worry. I like this quote, because in mathematics, you don't understand things, you just get used to it, in fact. So all the evaluations happening, because this is a part of mathematical and statistic science, everything will be tested with some formulas. So what do we do? Well, to evaluate our training, well, we first do the evaluation on our training data. Let's see that as homework. Okay? So you do first your homework, and if you don't do a good homework task, then starting on the exam is probably not a good idea. So all the tests I show you, you can do first on your training data, which is a bigger set. If this already fails, then it means you don't have to do it with your test data again. And the other one is then doing it on test data. That's really your exam. Do we see also good results there? And can we explain why the results are not good? Sometimes you don't have to worry always about that the outcome is not 100% what you want. If you see, okay, in our test data, we have, again, a lot of outliers in our data, and we can explain why it's off, it doesn't mean you have a bad model. Yeah? To learn more about regression models and evaluation methods and so on, I can especially recommend you the first link here towards data science. It's a very good website with a lot of articles about everything about AI and machine learning. Sometimes very technical, but also sometimes very approachable. Yeah? It was a very good help in these quests. So first is the easiest one to test. It's what you do is you have an actual figure and a figure that is predicted on your data set, and what you do is plot it on a graph. And what you would see in a good model is that you have somewhere a linear regression that is around. I wouldn't say this is the best model, because it's a little bit broad and we have some outliers, but at least you have a linear line. That's another model we trained. You see it's more spread around. There is not really a linear regression. You see even some patterns in there, so it's not that good. So you know already, don't use that. Don't further explore. We have to work on the figures. Second that you can test is have a look to the residual. So in that terminology, that's the difference between the actual value and the predicted value. And that can be positive and negative, and then you can do some calculations with it as well to see if your model is more over-predicting or under-predicting. But you put them on a plot as well. And if you see a little bit of cloud around the 0x, that is nicely spread around without any pattern, you know our model can be fit and be in the good direction. On the other hand, our other model it's not really a cloud, and you see a certain pattern, you see lines in there. So in this case, we know that model will not be a correct one. That's one that was overfitting. That is a model where we put a lot of a high minimum sample split, for instance. So then there's the bias. That gives a little bit an indication if your model is fitting or not, but it's not really accurate. So it is the sum of all the residuals, but you can have at the end a number of 0. That means, oh, it's not, it's very good. It looks like very good, but it could be that you have a lot of records that are 1,000 values off and 1,000 values in minus off as well. So that, yeah. But here you see a little bit, okay, my model is a little bit overfitting or underfitting. And then you can do the same for the main bias error. Yeah? A more used number is the root, the R squared, the root squared value is the percentage of the variation in your data model. So it gives back, in fact, a percentage. And the percentage that it gives back is how much of the prediction is due to your model. And so to give a little bit an indication of numbers that you get back, if you get a 90% or higher, you have made a very good model. That doesn't mean that the other models are not okay, but if you see 50 and below, then you know, okay, let's stop, don't use that model, play around, have a look to the data, have a look to the figures and try out. The mean absolute error is a formula just to see also the average distance between your actuals and predictions. Yeah. And here we take the absolute one to not get the overfitting and underpredicting of the value. That gives a good indication. And this is the one that Clarisse is explaining in his documentation. It's the mean squared error. That's in fact the same formula as the previous one. But here you say, okay, let's penalize errors by, mean square them, yeah? So that you have double effect. So if you have a prediction of 1 off, it's only 1, but if it's thousands, and there the square, mean square from, it's big. It's difficult to interpret because you get a number that is also mean squared. So it's good to do a root of them so that it brings back to the original value. So the value you get in this case is again the number of bicycle crossings that are over. Luckily, we have a good calculation engine in FileMaker, so we can easily calculate these. Yeah? The problem with this is if you start comparing models. Imagine you have a model that predicts the success rates of your project and the lead time of your project. And imagine you see that the same features are used. So you built, in fact, 2 models, one for success rates, one for lead time. How do you compare a figure from lead time with a figure on success rate? So in this case, it's better than to use some other figures that bring that back to a percentage. So here you see the difference between just using the average, the MEA, and the root mean thing. So you see our model is, in this case, 3 values off, 3 crossings off, which you would say, it's good. But you see in reality, if we do the other ones, you see already a figure of 108. Yeah? If that's okay or not, that's up to you to determine what is a good value or not. So if you predict, for instance, a taxi trip trip, and you see it's 5 minutes off, or if it's 15 minutes off in New York, you're fine. But if this is for an ambulance that has an emergency, and it's an hour off, that is not that good, or 15 minutes off, that's not that good. Yeah. So here is the other one, the MAPE, used a lot in regressions, and it's easier to interpret because it gives the value back in percentages. Yeah? So some calculation. Also here are some recommendations. If you see that this is under 5%, then you have a very good model. I didn't build any models at the moment in Claris FileMaker where I get that figure. The best figures I get is around 10%. Yeah? But the limited amount of data we had in our testing. There are a lot of other models and other evaluation metrics where you have to be a mathematician or have some experience with, need some experience with. But there are a lot of resources that explain this, because this is already used for a lot of years in science. So the good thing about this is that you find a lot of things. We picked a couple of them out of them that we have seen, okay, this gives us a good indication if our model is fitting or not. So if we go to our models, you see here, these were the figures it created. You see that's due to our data set very high, but you see that our MAPE here was 15%. Yeah? This was our bad model, and that's the one where you see all the spreading in there. You see this is giving 40%, which is not that good. Yeah? And here we played a little bit with the settings, and we came to a MAPE of 10%. And you could link that. Here we use the square root, 32 trees in this case, a maximum depth of 16 and a minimum sample split of 2, not too big for that small feature set. And here we have 100 trees, and we use the maximum features of 0, so all. Yeah? So prediction models or regression models, they are only predictions. So that doesn't mean they are exact. So here we see an example of something in our test data that is good. It's -2. Here we have 7. But we have also where he's almost 100% off. Yeah? Yeah? So that happens as well. So then you have to look in your data. What is the reason that this one? Is this an outlier? Is this something exceptional? Maybe there was an event that day, if you look up. So that could have an influence.
Okay, so now we are going to show you a couple bit more complex models. The first one is about whether you would survive or not in the Titanic. The dataset, we took it from the very same web page that Koen was talking about before, and there's a competition going on right now, so if you'd like to play a little bit, you already know. The information we got, or the features we got, were about the information of the passengers, and also, of course, we need to know whether they survived or not. The difference between this prediction and the model we did until now is that here we are looking for a categorical, a classification, right? It's completely different from what we found, but the regression model is always returning a number. So we will have to see how we classify it afterwards. So first of all, we take all the features that we have, the information of the ticket, the sex, day of birth, class, cabin, port, and the number of siblings, children, and parents. And we convert everything to numbers that we will put into our feature vector. We skipped the cabin information because most of them were empty, so it was not giving proper information. But we kept the port because we found out that depending on the port they were boarding to, there were more people going to first or third class, so it influenced whether they survived or not. So it was still a feature that was having influence on the results. So as I said, the result that we get from the regression model is never 0 or 1. It's always going to be a number. And the first idea was, okay, all of the numbers between 0.5 dead, all the numbers above 0.5 survive. But this is a kind of brutal separation because the distance between 0.49 to 0.51 is so close. So in this case, for example, we saw it was much better to define a threshold and say, okay, all the cases below 0.35 are dead. All the ones in between 0.35 and 0.65 are unknown, so they will have to be reviewed by a human. Yeah, there are some times that we need to flag some results, so they need to be reviewed by humans. And all of those who are above 0.65, we are going to consider that they are survivors. So let's see the Titanic demo here. We played a little bit. Already, Koen's daughter survived. Koen was killed. And of course, Jake from the film was killed as well.
So we know that the model is working. So, anyone volunteer to know if he would survive the Titanic or not?
Come on, René.
Yes, killed.
Wait, we don't know it yet. Come here, René. Yeah, because if not, they're not gonna. So, yeah, enter your name.
Yes, there's no GDPR there.
Haha. One, first, second, third. First. Yeah. Good taste.
Cheater.
Number one.
Yeah. Okay. How many siblings do you have?
One sibling.
And do you travel with you? Not. That's in fact the figure.
Do you travel with your parents?
No, I went solo.
No, you went solo.
Yeah. And I didn't have any children or.
Okay, so we are going to choose a model now. Take the first one. No?
Yes.
And are you ready? Let's see. Oh.
It works. Huh?
I'm sorry. Koen, you were right. Okay.
So it's a fun one to play with, but of course, in reality, you will not play with this kind of situation. But sometimes if a rating could be used, if you have a project to calculate if something is successful. And then it's depending or flagging things, so that you tell the model, okay, on this you can take a decision. That is okay. This one is not okay. So this should be trashed. And this one, some human have to be in the loop to have a look to make a decision what it will be. Yeah? On the other hand, if we look to our models, so these were the same models, and we have a look to our test data, you see that you can never 100% rely on it. So here we have a record where he predicted where the actual was survived, and he predicted survived. In this case, we had someone who passed away, and that was also provided. Probably someone from Belgium, if I see the name. So here, she survived, but the system was unsure. Yeah? Yeah. This is still okay. So she survived, but the system said it died. So if she would take the risk to take if she would have known up front, I will take the Titanic, and it will sink, but yeah, I will survive, so I get into New York. She could take that risk, but on the other side, yeah, we have some other outcomes as well, where the models say you will survive, but in fact you will pass away. So we stay in Titanic land, yeah. Now we're going to use a little different point of it. And in this case, we're going to train a model on movie sentiment, also with the same technology. So we're going to predict if the reviews of a movie are positive or negative. Yeah. So we used, again, a data set from Kaggle. And if you look here, we have here the rating, which is text, complete text description. So we see Bethany Cox is a big fan of Leonardo DiCaprio, yeah? And she has a very positive review. So our dependent variable we want to calculate, our prediction is positive or negative. 1 is very good, 0 is bad. But these are our features. So, and we told if you train a model, it has to be numbers. Okay? So how do you convert that to numbers? The good news is in FileMaker 2024, they already solved that issue. We use it for text embeddings to do semantic search. What is semantic search? And the LLM doing is converting text into vectors, into numbers. And these same vectors, these same embeddings, you can use to train some models as well. So not based on figures as features, but based here on text. Yeah? And the results are pretty good on this. So what do we need for this? Yes, in this case, we need or a Claris AI server with an open source model to create our embeddings, or a commercial LLM provider like OpenAI and Antwerp. So let's have a look to that demo. So this is our training set. You see it's a very huge set, yeah, 40,000. We didn't train due to the timing on the 30,000 records or so. We used 10,000 records to train the model. So it took a little bit longer, but our model was still okay. And so what is in there? Here you see data from Bethany, who is very happy about it. And some others that are positive. A lot of people are positive about the Titanic. Yeah? Surprised me. Yeah? And then we have our model. Right? So we have our here our embedding that is generated by the Claris function. Yeah? So you see that every record has a text embedding. So we had trained a couple of models. See? So we played with a couple of these parameters. And some results. You see the map is around 7, which is still fine. Yeah. And here, this is then our testing. So you see the text is negative, and yes, it's seen as negative as well. Here the text was positive. It's seen as positive as well. And here we have some more difficulties. Undecided, yeah, it's negative, but you see here, she is so gorgeous. So is it positive or negative? So that the model is confused, I can understand. Eh? And here we have another one as well that is positive but seen as negative, but there are also wordings in there about that are very negative in this text. So you can see where it's coming from, that the sentiment is not. So you see, we flag them. Eh? We didn't say, okay, it's 100% okay or not, but we flag them. And here we have completely wrong. Yeah, but he's a little bit cynic. I love seagulls, early movies, eh? And so that sounds like positive, but in the end, he's negative about the text. So we are nearing the end of the session. Where are we with the timing? Because we have a reserve chapter as well.
Yeah, 10 minutes left.
Okay, so we have some time for Q&A. Yeah. So what did we learn? Because we did not implement it yet at customers. It was for us a first exercise to have a look what is possible with these models. And since no one in the community was really looking to it and talking about it, we wanted to see what it could do and not do, and give some attention to Claris to work further on that technology. So we learned that it's key to work on your data. So just like with the LLM, your historical data is important, but it's also a good way to demonstrate to your customers what you can do with all the legacy data that is already in your system, without having to expose them to other systems. As a developer, the work was shifting because the implementation of FileMaker was very simple. It was only 2 scripts that we used. But it was shifting, in fact, to analyzing the data, have a look to the data, trial and error, see when adapting things, also clean up sometimes data for better results. So it's a very promising technology. I would like to see some other regression models, because the more I learn about and the more I read about regression models, the other regression methods are interesting as well. And I think it's something that can let old data shine in a new situation. Things where I'm thinking on in practice to implement is, for instance, find data back that is off in the database. So you expect somewhere that a code will be around or a project will have a lead time of that amount of time based on a lot of parameters, and to find back all the projects where that didn't happen. That could be an idea to use regression models, or to generate useful test data as well. So that you want to implement a new module and you need some test data to show some graphics and some reportings. And yeah, you know, always with this fake data, even if you ask OpenAI, you see some data that doesn't make sense. So sometimes there, but also in real cases like forecasting some figures that could be used in planning tools or in other kind of situations. So it's time for Q&A. If you have questions afterwards, you can always reach out to us. And we have an extra chapter as well about how you can do legal, think on the legal side of it. But that we kept in the slides for the material in there. So when let you a model do the predictions and take all the decisions himself, and when do you keep a human in the loop, in this case, what to consider also on the legal side. Yes.
Thank you. Just a question. If I understood well, you mentioned that you need to select the vectors of valuable data as inputs to train your model, so that you don't get noise, and the first names of the people riding the bicycle are not of use to train your model. But when you do that with IMDb, you use the embedded vector, where you will have a lot of noise because you have a lot of vectors which are not relevant to what you're training for. How do you assess that?
Well, that's why random forest is such a good thing. So that is why the randomization of the forest, if you would do linear regression or the other models, you cannot completely not use it. And I'm not a specialist in this, so I asked again my colleague as well, because how does it work under the hood? My internship, and she had to look up as well. The text embeddings are structured in a certain way, so that everything is a little bit that belongs together are there, but it's randomized. That's why random forest is a good method, because it randomizes all the features and all the things to have a better. So in this case, you should use a little bit more trees to have a more accurate system. But due to the randomization, you get a better average that gives a good result back. Yeah? Yeah.
Thank you for your presentation, Mireia and Koen. Thinking about performance, does it make any difference to store externally or internally the model into the container field?
No, the size of the model has a bigger thing. So depending on how big your model is, and I see if it's 3 megabytes, it takes already a while to load. If it's 4 megabytes, it can take very long. So be smart if you load a model that you don't unload it every time. So if you have a model that takes a little bit longer to load, that you load it maybe on startup of your solution, and then you use during your application thing. It all has to do with the size of the model, yeah, and the complexity of the model. Yeah.
Yeah. So you mentioned that the training the model takes a while, can take a while. Did you maybe test if it's more efficient to use a FileMaker client on in a local solution, or perform script on server and let the server do the training?
I did all the testing local in my case, because I wanted to see what happens as well and get some feedback. Because if something is hanging on the server, because some of my my figures I put in were off and crashed my system or let FileMaker hang as well. So it took 2 days and then not the result there as well. I would say most of my models run within a couple of minutes. So it wasn't, but I didn't want to have any interference of delay of latency or complex applications. So it's a good idea to export your data in a separate database, play with it, and I will try to make a new version of the demo files because there are some things in there that are hard-coded, scripted to go to the correct records and so on. But I will make a version available of one of the test files so that you can easily play with it, because at a certain moment we prepared a lot of models as well already in our records with all kind of settings, and then make a loop script and say, okay, train now the whole night all my models, and I will test all the test data afterwards. Yeah. And there was some pressure to have this ready for today. So, our first model was we tried to train, and that's maybe also a good one, a failure, because our first model we trained was on the taxi trip data, and it contained a lot of data. It's also on Kaggle available, but none of our models did actually work. Whatever we tried to tweak, and they became every time too big. So it will not only be a success. Yeah? Okay, thank you.